Hello everyone, welcome back to my channel. Today the topic is quantifiers. And if you're wondering what these funny looking symbols are, then you're in the right place. These topics, like quantifiers, are an important part of mathematics, computer science, and philosophy. If you ever wondered, you probably have seen it somewhere related to these three fields. And if you want to learn more about it, what this funny symbol means, then you're at the right place. Stick around because by the end of this video, you will have this or grasp of quantifier and how to use them. Let's consider a universal discourse, which refers to the total collection of elements under consideration for our analysis. Suppose K represent our universal discourse, especially the collection of houses. Now let's define a relationship between these elements called north of, represented as NT and read as north of. And read as north of. Using this relation NT, we can establish elementary proposition. For example, we can make a proposition and these elementary proposition, and each proposition, now these proposition asserting a certain relation, and these relation is that the A north of A, which is a house, if A is a house, and it is a north of A, which is a house, is north of itself, which in itself is not reasonable and it is false. So all these propositions, we can make this clear for every house, like every house can't be north of itself. So these are a collection of elementary propositions. Similarly, we can establish an elementary proposition for each house in the collection. However, it would be quite time consuming to individually write down all the propositions that affirm this relation for every house, that every house can be a north of itself. Instead, what we can do, we can establish a generalized notion. We can establish this proposition in a very general way. Like we can say, for every house, a house cannot be north of itself. And this generalization can be represented by this general proposition. Now, with this general proposition, we can say for all, the sign which is a flipped A, which is a called for all. A is a variable which can be substituted for each value of a house. So A can represent a range of values which belongs to a set of universe of discourse, of which is a collection of houses. So A can be A, B, C, D, E, F, any value we can substitute for A, and it can represent or affirm a proposition for each element of the universal discourse. By using quantifier, we can encapsulate all possible elementary propositions into a single general proposition, streamlining our analysis. What are quantifiers? Let's start with the basics. Quantifiers are special symbols used in logic to talk about the number of things in a particular group, known as the domain of discourse. Now, what is the main domain of discourse? Is if we're talking about a collection of objects and we want to assert a certain attribute, certain condition that all objects inherit or have, then we can use quantifier. There are two types of quantifier which I'm gonna show. One is for all, which is also called a universal quantifier. Second is there exist, which is called existential quantifier. In order to understand quantifiers, I'm going to present a very simple example. Imagine you want to talk about a collection object, like all the books in the library or all students in a classroom. Quantifiers help us express statements about every object in the collection, or about at least one objective. Universal quantifier. For example, let's take example here. So, universal quantifier, this symbol is used when we want to say something about every single item in our group. For example, if we say that for all x, which is, you can say that flipped A, which is read as we read it as for all X is a book, we are stating that every object we are talking about is a book. The universal quantifier is like saying every item in a collection is a book. Now talk about existential quantifier. This symbol, called existential quantifier, is used when we want to express that at least one item in a group has a certain property. How we read it as there at least one element exists which satisfies their property of being a read book, or at least one. Combining quantifiers. Things start to become more interesting when we start combining quantifiers. For example, let's take this example. For all x, there exists a y such that x is greater than y. In order to elaborate on that, let's take some visual example. Let's lay down our x values. Possible, let's lay down y values. If we consider this set of numbers, and we are restricted to x, then we can get for every x there exists a y such that x is greater than y. However, the order matters a lot in quantifiers. If we talk about the first statement, which says that for all x there exists y such that x is greater than y, then no matter what x you choose, you can always find a y that is smaller than x. This is generally true in mathematics, where for any given number, there is always a smaller number, unless you're dealing with a special case like smallest possible value in a specific context. However, the second one cannot be always true. Generally, it is always false. Why? Because the statement says that there is a specific value of y such that every possible value of x is greater than y. However, in most contexts, this isn't true, unless the domain of discourse of x is restricted. For instance, let's take an example. If x represents all real numbers, there is no single y such that every real number x is greater than y. Because for any real number y, there is always some x that is not greater than y. For example, x is equal to y and itself. If the statement is taken literally in the context of all real number, it would imply that y is smaller than every possible x, which would only be possible if y were less than all real numbers. In standard real number analysis, there is no smallest real, so this statement would generally be false. Simply put, there is no real number which is smaller than all possible real numbers. Why are quantifiers important? So why should you care about quantifiers? Quantifiers are everywhere in logic, maths, computer science. Let me give you one example from a computer programming. You might be checking in the example if all elements in a list meet a condition, or if there exists at least one element that meets a condition. This is quantifier in action. They are building blocks for writing proofs in mathematics, dealing with logical proofs, and so on. That's a wrap for today's video on quantifiers. If you find this breakdown helpful, don't forget to give it a thumbs up and hit the subscribe button. If you haven't already, Also ring the notification bell so you won't miss out on our next deep dive into logic and more. Got questions or want me to cover a specific topic? Let me know in the comment section. Thanks for watching, and I will see you in the next video.